Gravity in space is a weird topic. To most of us, it would be fun to spend some time just floating in space. Low gravity has even become a commercial thing, with many paying large sums of money to experience it for even an hour. To scientists and astronauts, though, low gravity presents more issues than they would like to admit. From reductions in bone density to problems with blood flow, low gravity can be deadly to astronauts, especially over extended periods of time. There are two main solutions, however, and these are much more realistic than the unexplained gravity common in science fiction. The most common way to simulate gravity in scientific textbooks and science fiction, specifically sci-fi stories that choose to actively tackle the topic of gravity, is the spinning ring. Films like The Martian and 2001: A Space Odyssey show off huge ring spacecraft that generate gravity through centripetal acceleration. This means that as the ring spins, the force that is generated pushes people on the inside of the ring outwards, and therefore towards what they perceive as the floor. If you get the spin just fast enough, it feels like walking on Earth. Futurists will know about O'Neill cylinders, huge cylindrical objects that can house billions of people with an Earth-like gravity. Centripetal acceleration makes these work. The problem with these rings is that they work best for craft with minimal force acting on it from elsewhere. Therefore, these rings are best used for space stations rather than, say, the Hermes from The Martian, as the thrust from its rear engine would alter the gravity drastically. Gravity on rockets can be achieved with the next method. The other major solution in science fiction is also a result of acceleration. The science behind this one is essentially the same, although it is achievable on a much smaller scale. This comes at a cost, however, as it cannot be used all of the time. Essentially, when a rocket thrusts forwards, it forces loose objects inside it towards the engine. This means that if you have the floors positioned so that your feet point towards the rear rather than perpendicular to it, you will be pushed down towards the floor. When the thrust from the engine ceases, inertia maintains gravity inside the rocket. The only issue is that you would not have gravity while stationary, and any maneuvers that increase or decrease the forward thrust would affect gravity too. If there was a sudden decrease in forward thrust, such as if force was directed from front to back, it would lower gravity very suddenly. Even worse, if there was a sudden and significant increase in forward thrust, it could crush someone or at the very least break some bones. Like most overly complex astrophysical stuff in sci-fi, The Expanse manages to do it best. In fact, both of these methods of generating gravity are used in that show, but it's the only example of a TV series where forward thrust effects on gravity are shown and explained. There are other crazier theories about the weird and wonderful ways that we could eliminate the risk of atrophy in low gravity, but these two are the ones we would use today. Science fiction fans and scientists alike can benefit from this quick synopsis, but for a discussion on how the two could benefit from each other, have a look at the Science Fiction vs. Futurism article on the Features and Video page.